Hi, in this video I'll discuss the preparation and reactions of acid anhydrides. So if you remember from the video about the carboxylic acid derivatives, the acid halide is the most reactive and then the acid anhydride is the next. So we form the acid anhydride from the acid chloride. So in this reaction, our acid chloride will react with the salt of a carboxylic acid. So this R group, if it's a benzene, that would be benzoate. Right, so I have a negative charge here. Usually, right, you don't see these oxygens that have resonance act as a nucleophile. But in this case, because the acid halide is such a good electrophile, and that carbon is very electrophilic, you will see this reaction take place. So I'm going to go ahead and number, this is carbon 1, and that's carbon 2. So now when I draw these together and combine the reaction, I got O minus here. I've got my chloride, and then oxygen. So that's carbon 1, that's carbon 2, and the oxygen in the middle is what reacted as the nucleophile. So my next step, the electrons will bump down, kick off the chloride. We've seen that process a lot now in these reactions. And there's our acid anhydride. Now these R groups aren't necessarily the same R group. Right, I'm just labeling them as R's to be generic, but this can be an unsymmetrical compound. Now, all of the reactions that we saw with the acid chloride will occur with the acid anhydride as well. The only difference between the two is what the one substituent is. In our acid chloride, right, we have the chloride here, acid anhydride, it's this leaving group instead. So all the reactions and the mechanisms are identical to each other, it's just the leaving group is different. That's the only difference between the reactions with the acid chloride and the acid anhydride. So when you're looking at the different mechanisms and reactions that can occur, just refer to the acid halide video, and you'll find everything the same. You'll just have a different leaving group.